Okay, these starters, we're actually going to reflect on those questions at the very, very end. But hopefully, let's get going. First and foremost, thank you for tuning in. My name's Tom Manners. There's my Twitter handle at Manomatics. That's what I look like pre-lockdown when I'm not cutting my own hair and can't be bothered to shave. And a little less grey hair there as well. But that's what I normally look like. I work for the NCTM as a teaching for mastery specialist. You'll notice I'll put the teaching for mastery in inverted commas because the word mastery means so much different things to so many different people. This is the second webinar I've done during lockdown. The first one was 90 minutes, all about what the NCTM talk about teaching for mastery. And in that, I kind of rip apart the idea of mastery because everyone has different opinions what it is. There's some great papers out there and great information about that. So if you haven't seen that YouTube link, I will send that out as well because I'm not going to lie, it was well received. I thoroughly enjoyed doing it, but it did share what I've learned through the NCTM. The Central Maths Hub, I'll talk about the Maths Hubs in a minute. I'm based in Birmingham, and that's where the Central Maths Hub is. I'm a professional development lead for the NCTM as well. The NCTM, I'm just saying those initials if you know exactly who they are. The National Centre for Excellence in Teaching of Maths. And those Maths Hubs, the government have put a lot of money in across England to try and improve teaching across England. There are currently 37 Maths Hubs. By the start of next academic year, there'll be 40 of them. But I'm trained, if you get involved with them, you can get all sorts of opportunities for training. I'll speak about that in a few moments as well. My job for 3 days a week, so for 2 days a week I work for myself, I do stuff for the NCTM and I visit other schools if they ask me to. But for 3 days a week, I thoroughly enjoy working in Sutton Coldfield Arthur Terry Teaching School. I'm subject pedagogy lead there for maths, which gives me lots of time to see the latest research in maths and to be taking in new ideas of what people are doing out there. I train teachers, an absolute joy, a job I always wanted. To take them from the very beginning, and so thoroughly enjoy what I do at Arthur Terry. I mentioned the Maths Hubs, and my advice to you today, well, after the show, if you don't mind, I'm talking now, but you've got time afterwards to go to mathshubs.org.uk. As it says there, mathematics education professionals in a collaborative national network. There are free courses throughout the academic year run by people like me, by teaching mastery specialists, by university lecturers, all sorts going on, lots going on in different areas as well. So my advice, very strong advice, please go to mathshubs.org.uk, join the mailing list for your local hub and see the events that are going on. Because there are a lot of events going on in each of them for all year groups as well, from early years up to Key Stage 5. So the NCTM, it keeps popping up on my screen, so I'm assuming everything's going okay, Adam, at the moment, just because something keeps popping at the top of my screen.
Yeah, everything's absolutely fine.
Brilliant, thank you. I'll try and ignore that then. The 5 big ideas that we use for teaching for mastery, here they are. And again, this was covered in my previous webinar. And today we're going to be looking mostly, of course, at representation and structure because Algebra Tiles is what you've signed in for. But these are the 5 ideas that are all interconnected, just like maths, all interconnected to help children learn for understanding. We should be teaching for understanding. We shouldn't be teaching to pass an exam. That's a sad state of affairs. I was very fortunate. A friend of mine said to me when I decided to train as a teacher, help them learn maths. Don't help them just pass the test. And I know in our profession, we start swinging the wrong way, don't we? We're worrying about that exam. And it is a necessity, but we want them to understand maths as well. We became maths teachers, didn't we? Because we love the subject. So one of those 5 big ideas is representation and structure. A representation of the maths, either using bar models or counters, and today Algebra Tiles exposes the structure. It helps children to understand what it's actually looking at, what we're looking at when we say 3x or x squared. Why are they different? Representation can pull out the concept being taught. In other words, conceptual understanding. And it can challenge a key difficulty point. And I think during today's examples, you'll see instances where what's the common misconception and how representing it with tiles will help overcome that. Some representations will meet over and over again. Algebra Tiles is one of them. And pattern and structure are related, but they're different because pattern might be a conceptual. And that's interesting. Someone's just written on my screen. And that's gone. Did you all see that? Did that come up on your screen?
It did. I have no idea how that happened, but
so, ladies and gentlemen, don't do that. I assumed I did wonder. Okay, we'll have to work it out and not let people annotate. Pattern and structure are related but are different. And pattern is about maybe the procedural understanding or the algorithm of how to answer stuff. But the structure of it helps us be the conceptual understanding. And I'm going to draw a Venn diagram with my fingers here. That sweet spot that we want for mathematics is the conceptual understanding, the procedural methods understanding, that bit in the middle there. We want them to have the conceptual understanding as well, of course, the procedure. But of course, this is not a replacement. And the first, I have to say, the first times I've introduced things like bar modeling and algebra tiles to schools, I've had staff often turn around and say, no, they need to do the proper maths. This is not the intention that in the exam they have algebra tiles next to them. It is to help us as part of our process of learning so they can do it without the representation at the end. Of course it is. There are going to be drawbacks to these as well. It's the right representation for the right instance. You might prefer bar modeling for algebra for equations, for example. I think it's certain types of equations better with algebra tiles, certain types of equations are better with bar modeling. I remember very, very clearly one of the first training sessions I ever did, and someone turned around to me and I was talking about bar modeling, and they said, oh, but that doesn't help the cumulative frequency. Correct. It didn't help for cumulative frequency. It's choosing the right representation for the right instance, for the right subject. Now, why should we be doing this representation? Well, the Education Endowment Foundation released this paper a few years ago now. If you're not aware of it, strong advice is to download it. Improving Mathematics in Key Stages 2 and 3. And it gives these eight bullet points, if you like. Now, what's good about this resource is it has red, amber, green worksheets, so you can go through, judge your department, judge your colleagues, or whatever, and say, right, what is it we're not quite doing yet in Key Stages 2 and 3? And there it is, number 2, use manipulatives and representations. And I've taken a slide from it, so here it is, and I wanted to make sure this was pointed out a little bit, because the majority of people listening today, I believe, are secondary colleagues. Of course, this was opened up on Twitter, so I don't know many of you. I have designed today for Key Stage 3 and 4, but when I spoke to some primary colleagues, they told me that this would be interesting to years 4, 5, and 6. So I'm hoping you'll be able to get something from it as well. But certainly this guidance report is huge for everybody involved with teaching maths. Manipulatives can be used across key stages, and if I just take my mouse and show where I'm reading from, it shows a clear rationale for using a particular manipulative. And that's what I was referring to beforehand. You choose the right representation for a specific mathematical concept. I am not going to say algebra tiles is great for everything we do today. Not at all. It's good for certain things, but I'm hoping by today you'll choose the bits that you want to use it for. Enable pupils to understand the links between the manipulatives and the mathematical ideas they represent. Absolutely, we're talking about the conceptual understanding again. We've got this limitation of concrete materials, and that's why we often use the words concrete, pictorial, abstract. We're still trying to get to the abstract at the end of the day. Trying to avoid pupils becoming reliant on manipulatives. Well, absolutely, they do need to do the exam at the end, but it is to give them that understanding, but we would remove those manipulatives with time. They should be acted as a scaffold, which can be removed once independence is achieved, absolutely. This final one I really think is very important though. Manipulatives can be used to support pupils of all ages. The decision to remove manipulative could be removed in response to the pupil's improved knowledge and understanding, not their age. So there is nothing wrong with using these manipulatives in Key Stage 4. Don't be put off by this guidance report saying Key Stage 2 and 3. It's for understanding and to remove those manipulatives when necessary. And I mentioned this before, here's a primary example. There's concretes, there's little number blocks there, which I'm very much, for anyone who has got youngsters, number blocks are a brilliant program on BBC. I'm thoroughly enjoying it at the moment. Concrete, the pictorial representation of the same thing, and then of course the abstract, which we need to get our pupils to. So today's session is algebra tiles. I look nothing like that, but I just downloaded this PowerPoint background years ago and I still like to use it. A few reminders before we get going. Again, please make sure that you've got your cameras off, please. Please don't annotate the screen. Also, we're sending out a video of this afterwards, so hopefully that will be useful for everybody. A few reminders, this session is put together by me, and the idea is shown on my interpretation of what I've learned. So I kind of don't want to put anybody in any kind of bad situation with regards to Central Maths Hub or my school after Terry, because this is me. I chose to do this. I want to share it with my trust. I love talking maths pedagogy, but it's my interpretation. And with that in mind as well, I'm hoping you're going to find the ideas interesting, and I hope you're going to want to use some of these as well. But what I really hope, and this is, you'll think this is wrong, but it is really true. I really hope you won't like some of the ideas. I really hope you'll see stuff and go, do you know what, I don't like that, but I could do it better. And that would be brilliant. Okay, if you've seen something you've been introduced to today and you can turn it around into how you're going to use it, that would be fabulous. At the end of the day, the reason I'm doing this is to talk maths pedagogy because I enjoy it, but also to help you enjoy your lessons and be more successful in the lessons you deliver as well. More about research into manipulatives and algebra tiles. Now, in fact, these paragraphs are taken from the EEF document. The literature review has loads of research behind it. Manipulatives offer powerful support for learners, which may be gradually internalized as the mental images take over. So they'll begin to see what an x is or an x squared, but of course, gradually we move that into the abstract. However, teachers need to help learners to link the materials to the mathematics, and that's why we cannot ever be replaced as teachers. We know how difficult this is during lockdown, and some of us might be using programs like My Maths, Hegarty Maths, whatever it might be. We can't ever be replaced because we're the ones who are going to make those connections between what they see and then actually what they've got to be able to do. And it's our job to link the materials that we're going to use today. Most of you are going to be using MathSpot, of course, so that would be the pictorial representation. It might be, I'm going to use some of the actual physical items that I've got next to me. But as it says there, appreciate the limitations of these concrete materials. We need to be the ones who advance it forward. Before we, in fact, no, let's talk about the national curriculum objectives first. And this is for all pupils. There are 3 assessment objectives that we teach to, if you like. And the first one is fluency. And the words that are very important to me are conceptual understanding. And that's going to be a really big part of today. The conceptual understanding, so they know what's going on. They're not just following an algorithm that they've blindly accepted is true. They've heard the word FOIL and suddenly they can do FOIL, but they don't even know what FOIL means. That's a shame if we end up doing that. Certainly in years 7 to 10, let's say half of 11, with 3 weeks to go before the exam, fine, cram. But still, conceptual understanding is surely what we're trying to achieve. The second assessment objectives, the tougher stuff, is when we reason, when we get pupils to conjecture, to argue, to justify what's happening, but also common reasoning problems at the moment are, here's a mistake, explain what's gone on. And then finally, solving problems, routine and non-routine problems. And that's not something we're covering necessarily today, but I am intending to do weekly webinars whilst we're in lockdown, and I'm sure I'm going to cover those sections a little bit. Adam, everything going okay from your end?
Yeah, everyone seems fine. If you've got any issues, just send me a chat message and I can try and sort it out.
Nice one, thank you. And a reminder that we will be recording this. Okay, so today's session, we'll be introducing algebra tiles, but then we'll do some examples with collecting like terms. We'll expand brackets and we'll also look at factorising. The next session, which I think I'll do algebra tiles next week. The next session will focus on the 4 operations and consideration of integers. So I think primary schools will certainly pick up more from that. Substitution and solving equations. Now, that'll be an interesting one because I prefer bar modelling for solving equations, but there are certain times I think the algebra tiles are more useful. And again, the right representation for the right maths. And that's why we're trying to meet the algebra tiles today. So what are algebra tiles? The NCTM have created a series of videos, and I'm purposely showing them as part of today so you're aware of them. Because I don't want you just to take what you've got today, I want you to take the materials and be able to use them in your schools. And as I represent the NCTM as part of from the Central Maths Hub, I thought it was important to share those resources with you. So I want you to be aware of those resources. So let's watch the first introductory video. Each time we go to a video, it'll be about 2 minutes long. And it will give me a chance to have a breather. So I will just click over here because it's as if I prepared it earlier on. What are algebra tiles, ladies and gentlemen?
Box of tiles in the classroom cupboard is 4. These are algebra tiles. But what exactly are they? And how can they be used in mathematics? Let's find out. There are 3 kinds of algebra tile. A 1 tile, an x tile, and an x squared tile. The value of each tile is equal to its area, the product of its dimensions. X does not represent any particular value. These tiles represent the idea of x being a variable. The reverse sides of the tiles are coloured red and represent the tile's additive inverse. To support teachers and students with colour vision deficiencies, you can label the tiles with their values. So, how can algebra tiles help students? Algebra tiles can help students to visualize and represent algebraic expressions. We can represent the expression x squared plus 2x plus 1 using the tiles. The reverse side of the tiles can be used to represent expressions that have negative terms. We can think of x subtract 4 as x add negative 4. And we can think of 2 subtract 3x as 2 add negative 3x. When using the tiles, it is important to understand that flipping a tile is the same as multiplying by -1. When we flip the tiles representing x subtract 4, we get the new expression negative x add 4, or 4 subtract x. Flipping the tiles for 2 subtract 3x gives negative 2 add 3x, or 3x subtract 2. Let's remind ourselves of the features of algebra tiles.
And there they are. So there's 3 tiles we'll be looking at: the 1 tiles, the x tiles, and the x squared tiles, and the reverse of the additive inverse, or the negatives of them. X represents a variable, and that's really important to make sure we're clear about. But flipping a tile, and that's why I wanted to show these videos especially, I think that line was very important, because that didn't occur to me until about 18 months or maybe 2 years of using these for the first time. Flipping a tile is the same as multiplying by -1. Now, whilst watching that video, I've decided to change the order of my presentation, because something that occurred to me. I'm going to scroll all the way down to the bottom here. The major thing to consider that comes to my mind, and I was going to do this at the end, but I think it's important to make it sure now. Take the time to ensure pupils can show a range of expressions using the required tiles. Trying to use these tiles later on, for whatever the subject might be, you've got to make sure they're happy with this manipulative. So as a matter of fact, before you start to use them, I think this is really important. Take the time to ensure they can show you a range of expressions. So ask them to show you 5, for example. Ask you to show you 5 in another way, hoping that pupils will consider 0 pairs. I'll tell you more about that in a few moments. Can you show me 5 another way and another way? Can you show me -2? Can you show me -2 another way? And then can you show me x plus 3? And can you show me x plus 3 another way? Considering orientation, and again, I'm going to go through those with you in a few moments' time. Show me x squared plus 3, so they know the difference between the x tile and the x squared tile. Get the kids this over and over again. Show me x squared plus 3x, and compare what the kids have got in the room. Show me one, show me another. So, just something that I'd planned for the end, but it occurred to me maybe I should do it a little bit earlier on. I think there's some chat popping up. Adam, is everything okay?
Yeah, absolutely fine.
Cool, thank you. Right, knowledge of the dimensions is crucial to their use, and that was explained briefly in the video there, that our x squared tile, the dimensions of it are x by x. The x tile, the length is x, but the width is 1, which means, of course, the 1 tile can fit onto the end, if you like, of the x tiles. Now, ideas that need to be challenged and understood, then I'm going to start playing with my tiles in a moment. The length of the x tile is irrelevant. Teachers must make this really clear. It's still a variable. Now, what I'm going to do now, if I just go on to, I've shown you this website today. I've linked you to Algebra Tiles, so hopefully you've all found this. I think at the starter I asked you all to go to MathBot, but I'm just going to go to MathBot. There's a whole website just to make sure everyone's happy with it. Then go to manipulatives. And there's Algebra Tiles just there, but as you can see, look at some of the suggestions here, how you can represent math. It's all free. Brilliant guy who's done this, MathBot, Jonathan Hall on Twitter, Study Maths. Fabulous guy, good on him. So these Algebra Tiles are the ones we'll use today. As it mentioned, you can label them if you wish, for those who are colorblind, which I am as a matter of fact, but I happen to be okay with these colors most of the time. Now, the reason I've gone online is because I wanted to show you this website as well. And what I will do is copy and paste this link. So if I go into the chat and try and ignore what people say, there's a link here. I'm just going to close that chat there because there we go. X tiles, I can vary the length and the size of the X. And I think that's really interesting. Now, I don't think this website is user-friendly, but being able to vary the length of the X, and look, if I wanted a Y as well, I can vary the size of the Y. I think that might be a really powerful thing to do in conjunction with the MathSpot website. One website I really have enjoyed, and I didn't know they've made it free again for a short while, because for the first time I ever met Algebra Tiles, I used this one, Braining Camp. And again, I'm going to go over to the chat and put that in there for everybody, and not read what people are saying, because I know it will put me off. Braining Camp is a free website, really nice manipulatives, really easy to use. Lots of free videos with it as well. Fantastic website. So I would be looking at those today. So what did I say? The length of the X tile is irrelevant. We must make it clear it's a variable. So I think that one website there really helps you remind children of that. But you notice how the width continued to be 1, which is, of course, incredibly important. This is the concept that Yip Ban Ha, he's the fellow who introduced me to Algebra Tiles. He is the person behind Maths No Problem, for those primary colleagues watching today. 5 equals 5. They are the same value. Equals is an important symbol to ensure people are using it in the right way, has the same value as. That equal sign doesn't mean this is where I put the solution to today's problem. It means they're balanced. 5 is the same as 5. They're equal to 5. And so therefore, we can say that 5 take away 5 equals 0. Therefore, 1 and -1 cancel each other out and equal 0. And it creates a 0 pair, as they won't affect our calculation. And I mentioned these 0 pairs, they need some attention before we start. So it's time for me to just shuffle across to the left-hand side of my room, where I am today. I'm hoping this will be quite clear for you. Adam, let me know at any stage if anything isn't clear. I've lost my marker pen, which is a bit of a shame, but I will try and do without it. So I've got a couple. I'm going to take all the tiles off screen. I'm going to make it a little less blurry, I hope. Seems to be quite blurry at the moment, so I'll just try one more time. There we go. I think that's okay. Hopefully you can see what's going on at least. So I've got 1 tile, and again, if I wanted the kids to show me 2, there's 2. If I wanted to show me 3, show me 3. Now, what if I introduce this tile here? This is the negative, the additive inverse of 1, so -1. And if 5 equals 5, we know 1 equals 1. That means this pair here, so if I cover that up, on screen now I have got 0. If I add another pair that look exactly the same, I still have 0. And that's a really important value. So I can leave that on the top right-hand side of my screen, and they can always stay there and still be 0. So now you can see 2. Even though this is still here, this is really important to realize that is a 0 pair. And that will help me when it comes to adding and subtracting of integers, which isn't what we're doing today. But when we're doing some collecting like terms, I think it was worth introducing it. We'll go in a bit more detail when I do integers next week. But I could put as many of these 0 terms here as I like. I am going to put them around the other way just to be confusing, because it's still a 0 pair. Let's get the X tiles out. I've still got 0. Apologies, it goes a little bit blurred every now and then, but I think hopefully you'll be able to cope. Yeah, I've still got 0 on screen. Pardon me. I've got 2 on screen, haven't I? I forgot about those 2. But this is a 0 pair. This is a 0 pair. They are not changing my values. I'm going to put another 0 pair on, and I'm not changing the value of how much I'm currently showing. Really, really important concept, which will help us as we go through our introduction to 0 pairs today. Now, I did say we'll do integers next time, but what's the same, what's different between these questions? So you've got these questions here. If you're doing 4, take away 2, maybe you can imagine having 4 on screen and taking 2 of them away. The third question there, you'd have 4, then take away 2 of the negatives. Do you know what? I will do that one. So I think that's worth me doing. So the third question there, 4, take away -2. Let's go back to my camera. I've got 4. And if I take away -2, take away 1 negative, take away another negative. And I'm actually doing what the question says. 4 subtract -2. 4 take away -2. So how many do I have now? 1, 2, 3, 4, 5, 6. And it's a way of making it really come alive, as opposed to this 2 negatives make a positive, which is an utterly irritating sentence to use because it isn't true in all circumstances. It doesn't help with conceptual understanding. When we as teachers say 2 negatives make a positive, are you talking about addition? Are you talking about subtraction? Are you talking about multiplication, division? You're not making it clear. It isn't clear. It's a sentence we shouldn't be using as teachers. But 4 take away -2, they can see why 4 take away -2 then looks the same as 4 + 2. But we've made the conceptual understanding very clear with example after example after example. So going back to what I was suggesting just here, we'll do a bit more on integers and practice next week. But 4 take away -2, aha! What's the same? Well, they're just the same. On the right-hand side, we are really just going to be using x tiles instead of the ones tiles. We can show about collecting like terms and subtracting x's, because that's what the algebra tiles really helps us do. We can introduce them the same way we do integers, and again, we'll look at integers in the next algebra tiles session. Okay, so collecting like terms. Let's do a few examples. So I'm going to just switch over to the screen again. Collecting like terms. Oh, do you know what? There's a video, and I want to make sure I do use these videos today from the NCTM. So if I click, oh no, my Zoom thing is going to get in the way constantly, isn't it? Let's see if I can be clever with this. I can be clever with this. Collecting like terms. That's what the NCTM have got to say.
Collecting like terms often causes students problems, but we use this idea all the time in number calculations. Let's look at how students can use algebra tiles to help them understand like terms and the idea of collecting like terms. First, let's look at identifying like terms. We can represent 3x and 2x using the same type of tiles, that is, x tiles. They are like terms. Similarly, x squared and -2x squared are like terms. We can represent them using the same type of tiles, that is, x squared tiles, even though one term is positive and the other is negative. Now let's look at grouping tiles to identify 0 pairs. We can represent the expression 2x subtract 1 add x squared add 4x subtract 2x squared add 3 using the tiles. The like terms in the expression are represented by tiles of the same type. We can group these tiles together, making 0 pairs easier to identify. There are 2 0 pairs in this expression. We can remove these tiles as they have a value of 0. This gives the simplified expression 6x add 2 subtract x squared. We can simplify expressions with no 0 pairs by collecting like terms. Here's an expression with no 0 pairs. We can group the tiles that represent like terms when we first lay out the tiles, rather than putting them in the order they appear in the expression and then sorting them. This speeds up the process of simplifying expressions. We can now write the simplified expression directly from the tile's representation. Watch these videos to learn more about how to use algebra tiles in Key Stage 3 mathematics.
We're going to see 2 more videos of those today, but those videos do exist on the NCTM website. Okay, let's go back. So me demonstrating a few examples, that's what I was going to do, wasn't it? So me go back to the camera. I just want to put those on screen. I hope you can see those. I've typed them onto a sticky note. We checked just beforehand, and I was told we should be able to see them. So
yeah, it's all fine, Tom. You can see everything.
Nice one, thank you, Adam. Okay, so 3x plus 2x, absolutely. So I've got 3x on screen at the moment. Again, it does just go blurry every time I move, so apologies. Hopefully you can be able to cope with that, people. 3x, and I add 2x. And that's why it's so important that you take the time to make sure children can do the representation of what each of these mean at the very, very beginning. 3x plus 2x. What is 2x? Show me 3x. Show me 3x again. And that's why I mentioned the 0 pairs earlier on. I still have, I'm going to put those there. I still have 5x on screen. Even though this 0 pair has popped up, of course, it has a value of 0. So I've got 3x plus 2x. Then I've got 5x take away 2x. So I can just do as the mathematical sentence is asking me to do. I have 5x. And I take away 2x. So the x is still there. I have 3x. So this really helps challenge misconceptions. There was 5 x's here. I'm going to put them back. I have 5 x's. I am removing 2 x's. What do I have left? I have 3 x's. The importance at the start, making sure pupils understand what each of these tiles represents, is incredibly important. Now then, I'm going to put some more 0 pairs on. Okay, 3x, take away 5x. I've got 3x. I'm going to take away 5x. So take away 1, take away another x, take away another x. And here the power of 0 pairs really comes in, because I can keep taking away x's. I'm going to take away that one. I'm going to take away that one. I had 3x when I started. I took away 5x, and I'm left with negative 2x. Really shows the value of those negative pairs, doesn't it? Then what I'm asking for what? So 2x. So there it is. 2x. 3x squared. Wonderful. And then take away 3x. Well, actually, I could say that as a slightly different thing, because I said take away 3x. Actually, we could read that sentence as 2x, which I've got at the top of your screen, 3x squared, there they are, and then and 3 negative x's. And that's maybe another thing that's important to try and share here as well, that negative 3x is the same as adding, although adding negative 3 negatives x is the same as subtracting 3x. And there it is there, negative 3x. So the expression is quite clear, but look, I can make some 0 pairs. Because I've made some 0 pairs, they have no value. So I've simplified the expression now to 3x squared, take away 1x.
Tom?
Hello there.
Would you be able to do that without starting with the negative tiles?
Okay, so in other words, just be doing it with positives to start.
Yeah, just if the kids if they set it up like I've got 2x and I've got 3x and they're all black tiles, like how would they know that then goes to a negative 1x?
Okay, so I think as maybe suggested before, and I'll scroll up again to put that on the screen. Well, in fact, it's down, wasn't it? Because we're referring to it now. I would be making sure when you start to use these, take the time to ensure pupils can show a range of expressions. Okay, so be sure that they're confident with negatives. Now, I would agree with you actually that you maybe start with just positive x's, so 3x plus 2x, 3x plus 7x, 3x plus 4x, 4x plus 2, whatever it might be. Keep the positives, but then maybe progress to the negatives so you're not bombarding too much too quickly. Now, because I'm assuming majority of people listening today are maths professionals, the questions I'll be giving you to do in a bit won't take ages over positives and then some negatives. But I think what your point there, Adam, is ensure pupils can show a range of expressions before. So I would take the time when you're introducing tiles for them to understand that this is this one here, just clear everything else off screen, that is negative x, that is positive x.
Yeah.
And take those times and make sure, I mean, then if I ask people to show me 2x, so going back to that example, show me 2x. Brilliant. Show me 2x still. Ooh, the orientation changed. Who cares? It's still 2x. That's really, that's worth doing and worth examining. But show me 2x. And I'm still showing you 2x. Yeah. So that the importance of that 0 pair, I think Algebra Tiles could go wrong if you try to go straight into the representations without having the children understand what those representations truly mean. So don't rush them. Do not rush them, because if we get these right in the when you want to introduce them, which could be upper key stage 2, lower and certainly year 7, then you can use them for years. Don't. Yeah. So really take the time to say, understand what these things are. Otherwise, it could just be a lost opportunity. And also, if they don't understand them at the start, they're going to be a little bit, what's the word, reticent to using them in the future. So at this stage, I've demonstrated a few examples and I showed you an NCTM video, which again, I'm doing those so you can use them at home. It's at this stage, I suggest you do a split screen with my stuff on the left-hand side. I had to put a photo of me and you playing online. So I've given you those 2 links already in the chat. So my suggestion is to minimize, if you like, or split it so you can play on the right-hand side. And I'd like you to try and simplify those following expressions. So I'm going to give everyone a chance just to play for a while. I think that's really important when you do this training. Have a go at these questions with your tiles. What misconceptions do you think are being uncovered whilst we go through these? What interesting AO2 type questions, reasoning questions are you discussing maybe whilst using these tiles? So I haven't got a clue what the time is because I turned my phone off. But
you've got about 20 more minutes, Tom, till 11.
Say again, sorry?
So if you go into 11 o'clock, you've got 20 more minutes.
Half 11 is the absolute end, and my hope is I was hoping at 90 minutes I expect. I think it's going to be about 75, 80 minutes to be honest. But can we give 3 or 4 minutes of people just going to play with those questions?
Yeah, can you just put the links back up?
They are in the chat facility.
In the chat. Lovely. I'll try
with them for everybody. Okay. And we'll sit here quietly and I'll wait to see if there's any questions.
Tom, are they the ones with the technology.cpm?
Yeah, so let me just go back a screen then. So you've got mathbot.com manipulatives tiles, and then the technology one. I only put that one up there because you remember that was the one that looked different sizes. You could vary the size, which of course, as we're trying to introduce X as a variable, not a letter, as a variable, I liked the idea of it being able to change. So I thought it was worth sharing that as well. But just a few examples for you to try.
Tom, just as people are doing that, can you hear me?
Yeah, go on.
Yeah. So a couple of people are just asking about purchasing algebra tiles.
Yeah.
We'll to that later on, but
well, I don't work for the BBC anymore, so I can say anywhere I like, can't I? I have to say that the set you're seeing me play with, I bought on eBay for myself. They cost £6. If you want to buy class groups of them, now there's a conversation with them. There's a conversation. You imagine you had 30 children in the class. Would you want 30 sets of tiles? I would. I have seen class sets sold in groups of 15. I think that makes a lot of sense, that the children are talking about it. It's an opportunity for the reasoning while they're discussing and making those expressions together. So the class sets are available. Is it TTS is a very popular place, isn't it? For
yeah.
So I think TTS sells them. I've seen class sets sold for about 60 odd quid. Yeah. I think. Now, I have seen someone who pointed out, yes, you can make your own. I know one school who created their own because they did it in their technology department. That's fantastic. I tried to make my own and cut them out. It was horrendously long-winded. And what happened was the accuracy for cutting them out, for me, on paper, was terrible. And so when I wanted it to be absolutely accurate, and we'll come to accuracy later on when we're looking at factorising, it was important that all the shapes were the right size. And so me cutting it out didn't make it work. So if you're more pedantic about that kind of thing than me, great. You can print them out. You can see ones for free to print out. It didn't work for me though. They're awful.
So if you haven't managed to get onto MathSpot yet, I've put that link back in the group chat. So you can just copy it straight into your browser.
Nice one. Cheers, Adam. I'm actually going to put my phone on, but put it on flight mode so I'm not getting any calls, but so I can see the time then, so I'm a bit more aware of what's going on. I'm not just checking my text, please. You'll have to excuse me. It's not even on yet. If any people have got any questions whilst doing this, please let me know. Any thoughts, actually, anything that you're thinking about? What misconceptions, I mean, the questions there, what misconceptions are being challenged by using these tiles? That an x is different to an x squared, for example. But anything that you're thinking, please share ideas today. I know on a webinar, it's not the easiest thing to do. But any ideas that come up on the whilst doing this, please do share it. And again, like I said at the start, if there's something you don't agree with all I say, and you could think of a better way of using it, that's fantastic. Okay, I think the most important thing I do when I do teacher training is to get people to make their own ideas here and to be able to suggest their own ideas to what they want to use them in the classroom and ways that they might want to use them. So in no way would I take any offense if people want to disagree. Just be polite about it if you do disagree with me.
Yeah, if you want to ask like an actual question, I can unmute you for like a minute, so you can ask Tom a question, and then
type in, be fine, I'm sure, as well. But we'll go from there.
So Tom, somebody's asked, can you eliminate the 0 pair on MathSpot?
Ah, okay. So now, can you eliminate the 0 pair? Now, MathSpot doesn't. If I have one, and then the next, if I put it on top, isn't it? Yeah. So yeah, so it's putting it on top. The Braining Camp one is very good for that, actually. I've always found the Braining Camp to be the most useful, but because I haven't used it for a year because I didn't realize it was free again, I only found that out last night. But yes, absolutely. You kind of want them on screen to have that conversation. But yes, there you go. It deletes, which is quite a nice feature.
Just staying on that, Tom.
Yeah.
You just asked, when you flip Y, you still get a red tile. How do you tell the difference between X and Y? And I'm not sure if that's on MathSpot or if that's
That'll be on this one, won't it? I imagine. Good question. Well, that's where the labels probably come in. I mean, in fact, if I look at my own tiles, in fact, all the red. So if I just went to my camera, the X tiles, turn them over, they're red. The ones tiles, turn them over, the red. The X squared tiles, they turn over the red. I think that is just a feature of algebra tiles, kind of generally accepted. Not ideal, but of course the labels come into play for that as well. And that's the importance, though. Again, so and in fact, I'm going to put it back on screen because I think this message is the more I'm talking about it today, I think it's really important. You've got to make sure that the children are able to use this range of expressions. Now, I think the point that because someone's mentioned Y there, I purposely, you see the final example I put on here. It's a limitation. Okay, it's a limitation of the algebra tiles. If you do not have a Y option, then that's something you've got to talk with the pupils, because again, the physical tiles that you buy, they don't have Ys. And so that then becomes part of a discussion. But you notice, of course, it's brought in quite late on. Now, by using that other website, so going to Braining Camp, I think had Ys. Yes, it did. This one, I think it's an American website. They had Y tiles as well. They've used different colors, but they've gone for, you can, as I said before, you can vary the sizes of them. I think that's just got to be very clear that you're going through the knowledge of using them a lot at the start. I'm going to move on. Obviously, you'll have time to play with these when I finish talking. So I think just having a couple of minutes to play with the website there was useful. So come on back. This is when you imagine the classroom, you've got 30 children. And this will be some things for some people where they're worried about them playing with the tiles. I'm afraid we have to do behaviour management, people. Hands off the tiles, please. Face the front, etc., etc. That is a drawback for some people, but it shouldn't stop you using these. And that's what I strongly urge you. Just because we're bringing something new into the classroom, the conceptual understanding, the benefits from it are going to outweigh the behaviour management things that are needed. And if you train them from the beginning to use them properly, so year 7s especially, what do you want to do with the year 7s in September? And I'm looking at the camera here to make sure it's really going through to you all. Train them to use it properly in year 7. Adam, I think you had a question then, sorry.
No, I'm fine.
I just came up.
I don't.
Cool. I want to talk about interesting AO2 type questions, so I can send you to other resources that I found whilst doing my research. Now, AO2 are your reasoning questions, getting pupils to talk about what's going on in the maths. This website here, if you look at the top right-hand side, Algebra by Example. It is an American website. There's loads of good files, questions like this. So they give an example of it, very much like the GCSEs are doing now, the AO2 questions, an example of what the pupil's done, and then discussion using proper words, so using the proper mathematical language, not just following a routine, following an algorithm, which maths, when it's taught boringly, that's what we do. Here's the question, do it this way. KFC, do it again. KFC, do it again. There's no understanding going on. It's just following an algorithm. These kind of questions are fantastic. They're all free. So algebra by example, I strongly urge you to go and have a look at it. I think the questions it sets are fantastic. But with that, it means the pupils have to use the proper language. There has to be proper reasoning and discussion in the classroom. Really, really, really good example. And as I say, sorry, it is free. It reminds me a little bit of other good examples of AO2 questions, a Clumsy Clive. The fella Alatwich has put them all on for free on TES. In fact, I'm pretty sure I left it open on here so I could quickly get it. Aha! So Clumsy Clive on solving solutions, Clumsy Clive on indices, all sorts there, where I know it's a bit small on screen now, but it's got expand the brackets, what's the pupil done, discuss what mistake they've made. There's loads of them. It goes into A level as well. Adam, I know, uses these as well, and Adam, I'm sure, will promote them by saying, yes, they're good.
Yeah, and there's the A level one is, it's got a different name, which I literally...
Yeah, they've used all sorts of names, so it's not just...
Erica's Errors.
Erica's Errors, that's it. Really good resource. They are free. You can pay to download in one go, but if you just do them individually, they're free. But good on him, the fellow who shared that. He's good on Twitter as well, Alatwich. There's his username. But good on him for creating all those really good AO2 questions, making sure pupils have to use the language, not just doing the algorithm. Okay, so let's move on to expanding single brackets. And I think the language we use here is very important, that we're demonstrating these. So here's two examples that I'm going to do. So I need to go over to my camera again and just make sure I can see what those examples are. Here they are, prepared earlier on. So this here says 3 lots of x plus 3. 3 times x plus 3. Now where's I had my pen. I found it during the, excellent. I want to write down this one, because for 3 lot 3, we know a common answer is this. Okay, we know that's a common mistake. So how can Algebra Tiles help overcome that? Well, let's go for 3 lots of x plus 3. But what about 1 lot of x plus 3? There you go. I've got 1 lot of x plus 3. However, I don't want just 1 lot, and I apologise it keeps going out of focus. That's just...
Tom, on the top of your visualiser, there's a little switch. If you switch it, it will stop doing that.
Is it okay? Brilliant, thank you. Okay, brilliant. Yeah, this is your visualizer, isn't it, that I've stolen, let's be honest. If I've got 1 lot of x plus 3, there it is. But the question says 3 lots of x plus 3. So here's another lot of x plus 3. And here's another lot of x plus 3. Oops. There it is. And I've got 3 lots of x plus 3. So we can see the 3x. There it is. Equals 3x. And we can see this, which doesn't equal 3. Whoops. 1 minute to be a plus. 3x plus 9. And we can see, of course, with time we go to the abstract, that 3 lots of that and 3 lots of that. We can really see it happening to make sure that error doesn't happen. Really, really important one there. What have I got next? 2 lots of x squared plus 2x. So let's just get rid of this paper. Okay, what have I got? So x squared plus 2x. So again, making it really clear, we can see they're different. But I want 2 lots of x squared. So there's another lot of x squared and another lot of 2x. So what we're seeing, 2 lots of x squared plus 2x. Well, we've got 2x squared. And how many have I got? I've got 4x. Really visualizing what's going on, as opposed to just, well, by not doing this, we're surely not giving that opportunity for the conceptual understanding. So I think these really good examples of expanding brackets. However, I'm hoping there are people shouting at the screen right now, because I think some people will realize we can do better. I have missed an opportunity here. I think using that language, 3 lots of x plus 3, and seeing them happen there, and using the example I did where I had the circle of them, 3 lots of x and 3 lots of 3, really important, 3 lots of. However, there's an opportunity which Algebra Tiles begins to grab, and that's going to be the real thread now from what we do to the end. Teaching for mastery, those 5 big ideas, we're making connections throughout. And this line is taken from the national curriculum. Mathematics is an interconnected subject in which pupils need to be able to move fluently between representations of mathematical ideas. And so it's our job to make connections within maths. And so where could I make a connection when it comes to these tiles here? So we go to the third of the Algebra Tiles videos. Just got to get to it a different way. Using Algebra Tiles, but expanding brackets.
We know that length multiplied by width gives us the area of a rectangle. We can use Algebra Tiles and the area of a rectangle when working with expressions. Sometimes expressions contain a bracket that we want to expand. Let's see how Algebra Tiles can be used to represent this. Let's look at the expression 2 multiplied by 3x plus 1. This is a product with 2 factors, 2 and 3x add 1. It can be represented as a rectangle. The 2 becomes one dimension of the rectangle. The 3x add 1 becomes the other dimension. We can use the tiles to represent the area. We need x tiles and 1 tiles to complete the rectangle, as these tiles have dimensions 1 and x and 1 and 1. Using the tiles to represent the area of the rectangle gives the product 6x add 2. When finding a product where both factors include algebraic terms like 2x multiplied by 3x add 1, the x squared tiles are also used. Sometimes the x tiles are placed vertically in the completed rectangle, and sometimes they are placed horizontally. Labeling the dimensions of the rectangle with the factors helps to determine the orientation of the tiles. So, let's recap how we can use Algebra Tiles to represent expanding brackets.
Now, some of you will start thinking now, this has got huge advantages when it comes to multiplication. We'll talk about factors and factorising later on, but you maybe even see links to A-level here. The links that we've got to area of a rectangle is absolutely brilliant. So we'll come to factorising in a few moments' time, but let's just look at expanding brackets currently. So going back to the presentation, if I would. Making connections within maths, and there it is, that's just taken from the screen. Products with 2 factors can be shown as a rectangle, and the area represents the expression that we've created. The 2 factors become the dimensions of the rectangle, the length and the width, and that area with the tiles gives the product. Labeling those dimensions helps with tile orientation. I pointed that out earlier on, of course. An x squared rotated continues to be an x squared. Now, this is a bit where I lean to my left and I grab my copy of Craig Barton's book. I'm sure many people have got it now. This image about connections in the brain. And it's our job to make connections. So if I go back to this, maths is an interconnected subject, and it's our job as teachers to make those connections clear. And if we can make those connections with expanding brackets to area of a rectangle, we're doing something here really quite smart. And I'm going to read from Craig's book, if I may, for a moment. Students learn new ideas by reference to ideas they already know, making connections between the stuff stored in the long-term memory over here, assuming that knowledge, of course, is present. And so if we're making those connections to stuff that's already in there, the circles you look at, or say the ovals, sorry, you're looking at, there, the schema, the units of knowledge inside the schema there, they're all connected. And of course, the more connections, the more strong, if you like, the schema are going to be. And so there's a lovely quote from Willingham: understanding is remembering in disguise. In other words, are we making connections with previous learning? If you introduce FOIL by itself with no connection of anything else, it's a lost opportunity. FOIL only has one limited use. Factor bugs only have one limited use. But if we're talking about factorising and linking it to it, be quiet, you Adam. He knows why I mentioned that. Yeah, when we're linking it to a rectangle, then we're making connections in the brain, and it comes into the working memory. So I'm going to repeat that expression from Willingham. Understanding is just remembering in disguise. I really, really like that. So maybe when you use algebraic fractions, making those connections to non-algebraic fractions really, really helps. Of course, if that form of knowledge is in the brain. Then new ideas, information, and procedures become assimilated into existing schema. As you can see here, existing schema, creating a brand new connected one, it changes the long-term memory. And so those connections in math are really important, because maths is this interconnected map. I don't know if you've seen, look at Mark McCourt, he's made this huge map of mathematics. It's a YouTube video he's released recently, where the whole of maths is just showing all these interconnections. It's our job to make those connections clear. So expanding single brackets, I'm going to just do a couple of these. In fact, no, I'm going to have you go a couple of those, aren't I? So I'm going to leave these on screen for a few moments for you. And I've purposely, some of the questions I've purposely linked. So try and go through them in order and think about what difference it makes, how you alter the tiles when you do it. So I'm going to go quiet for a couple of moments to let people have a go at those. Adam, any questions that have come up or any problems? I think the way we're going, we'll be done by 11:30, by the way. Looking at the time now, as it's gone 11, I think we will be done by 11:30 no matter what. I will stop talking by 11:30, I promise.
It's just there was a good point by Lee, who
Hello,
just talked about how it's really important that you make reference to the size of the tiles that actually it'd probably be easy if you just read it on the chat, Tom. It's only a little bit higher up.
Okay.
It's a really good point. Maybe something you can just make reference to.
Lee, hi Lee, thank you for that. Possible misconception: Dean's blocks are similar to these. Yep. Next one's would need to ensure that students use these manipulatives. They don't carry this place value system into the use of algebra and still consider the larger. Yeah, because the problem with algebra tiles, I think, is that when we do it as a representation, it's 2D, but holding it, actually, I'm holding a 3D item, aren't I? And Dean's blocks are all about volume. Dean's blocks is about the volume and 1, and then you've got 10 lots of 1 and then 10 lots of 10. Whereas really algebra tiles is about area. So yeah, really valid point about that, actually making sure they don't carry the place value system into this. Consider the larger 2 blocks as variables and don't just compare them by size. Yeah, it absolutely is something to consider. Thank you very much for that.
Yeah, that's about it at the moment.
We lost many people. We're still over 115. That's nice.
Yeah, no.
50 didn't sign in, but I'm assuming they'll wait for the video.
Got a question. So for the third question on your screen, do you do 2 sets and flip all of the tiles?
That's what I like about it, that question, because at the very beginning we talked about multiplying by -1. So I thought that would be an interesting one to people. If you've done the previous one, so 2 lots of x plus 4, I'm just going to get it ready on my piece of paper, and I'll go through that one if you like. But I think people will come up with different ways of doing that. I don't want to take these off screen at the moment, just because is there a way of me freezing? I don't think there is, so no, I can't go onto the camera for some. So I'd have to wait a second. I think if you know that -2 is -1 lot of 2, then it is a reminder that yes, you're flipping everything, because you're multiplying the question 2 to question 3. You're multiplying by -1, aren't you? So therefore, yes, everything gets flipped. And that's why I really like that concept of the expression multiplied by -1 flips the expression, flips every time. I hope that answers the question a little bit, but we'll maybe represent that one in a few moments.
Yeah. Just another one. So do you try and justify why multiplying by -1 is flipping the tiles, or do you just define it that way? Have students ever questioned that before?
I think when you're introducing the tiles, I suppose it is, you say this is what's happening. It depends how they've met negative numbers, isn't it? Because when they're meeting negative numbers in primary school, they're not doing the 4 operations with them. But I would imagine many primary schools will be showing red and yellow counters. And so they would get the idea that -2 is 2 lots of the red counter, for example. And any primary colleagues who want to shout up on this, that would be really interesting to hear. But the idea of saying it's negative lots. So imagine introducing 2 negative types. Do you know what? I'm going to have to go onto the camera for that, I think. So if you'll excuse me just a moment, I think I'm going to have to, otherwise I'm not making sense when I'm talking. So I've got 1 lot of -1, and I could write next to that, got 1 lot of -1 equals -1. I could go 2 lots of -1 equals -2. And it's making those links, isn't it? So if I've got 2 lots of 1, and I suppose I would just, sometimes some things have to just be explicitly pointed out. 2 lots of 1, there it is, equals 2. 2 lots of -1. And so in fact, it's the same as flipping it. Does that make sense? Have I said that in a nice way? I don't know if I have or not.
I think, I don't know, the actual tile has the same like absolute value, doesn't it? It's like they are the same.
That's what I find really interesting. I think when I want to do integers next week, I've got this idea in my head about how I've always wanted to use them, and I've never had to use negative numbers since teaching these. But then you've got 3, then you've got 2, then you've got 1, then you've got 0, then you've got -1, and you can see that -2 and 2 have a real relationship.
Yeah.
But you can see which is greater on the number line, because the number line, of course, goes that way.
Yeah. Yeah.
And there's the nice 0 there. But yeah, we'll look at that a little bit more next week. Just because it's been mentioned, 2 lots of x plus 4. So let me just get it. And I'm talking about areas of rectangles here, aren't I? So I'm going to make sure I do it as a couple of rectangles.
Mm.
Okay.
Just as you're doing that, someone's just said that there's a little link to integration and areas under curves, which is interesting.
Beautiful. Love it. In those connections in maths, people, it's so important. So there it is, 2 lots of x plus 4. Now, this is where I struggle sometimes. And I'll show this on MathPie in a moment, actually. That dimension is 2. That dimension there is x plus 4. I'm sorry that I've done it so close to the thing above, so let's get rid of that. 2 lots of x plus 4. Now, if I make that negative, that means I'm flipping everything that way, aren't I? So yes, it would flip. So the way I'd see it, so for the question below, I'd be flipping absolutely everything. I don't know why that made me giggle. But yeah, I think that's how I would do it. -2 lots of it. So you talk through each time. So maybe if I break that down again a little bit slower. So -1, -1. There's x. Well, -1 times x is -x. -1 times x is -x. Take your time over them. There's not a big rush here. Yeah, so 1, 1, 1, 1, -1 times 1, and so on. I think as I pointed out a couple of times, making sure we're really quite comfortable about them at the beginning. And I'm not going to say I am an expert at these. I keep changing how I want to do them, and that's why I pointed out at the very beginning today. I really want people to come up with their own ways how they use these. But those are the questions I asked. Now, this one here, you may notice I'm linking to, well, I will be shortly, linking to expanding double brackets. So I'm going to move on. So again, calling everyone back in the room. Moving on to expanding double brackets. Still on time for finishing by 11:30, so we should be good. I promise. But expanding double brackets, and I've made my feelings a little bit clear about this, that I'm not a fan of the word FOIL because it's so limited in its use. It only works when we've got 2 terms in each, 2 items, if you like, 2 terms in each bracket. It's very, very limited. It doesn't support conceptual understanding whatsoever. So for this example here, x plus 3 and x plus 2 times x plus 2, there are x lots of x plus 2 plus 3 lots of x plus 2. So just want to make sure I'm making that really clear on the camera. So I've got x plus 3 on my screen. Yes, I am. That is very similar. In fact, let's be honest, it's the same as this. And when you're practicing expanding single brackets, we tend to advance to this bit where we expand and simplify. And if I've got x lots of this and 3 lots of it, I've got x plus 3 lots of it. And I think that's really important, because we then see it, certainly with the visualization of this, when you're using the algebra tiles, you would see x lots of x plus 2. I haven't done a very good square there. I apologize. That's awful. That's awful. I apologize. Do you know what? I'm getting rid of that piece of paper. It's annoyed me. So I would have an x dimension there, an x dimension there, an x squared. What was the question? I've thrown it out the way now. Pick it up off the floor. There it is. 1. So 1 times x. Another 1. 1 times x. So we can see x lots of x plus 2 is that. I would then be able to do 3 lots of x plus 2. So there's the x. There's 1. There's 1 again. Fine, let's do that. What was it? 3 lots. Brilliant. So 1, 1, 1. So I'd have 1 there. Yes, I've gone for the representations. And again, after a while, you want the children to draw these, because I can see some people, I would imagine some people are very nervous about wanting to use these. But 3 lots of x plus 2. So on screen now, you've got x lots of x plus 2 and 3 lots of x plus 2. And you'll notice, of course, I could have put these together into one nice big rectangle. Now, foil, the reason I'm not so keen on foil is things like this. If I've got x plus 3, x plus 4 plus y, foil suddenly is completely redundant. Foil has such limited usage. But if I now have x lots of x plus 4 plus y, and I've got 3 lots of x plus 4 plus y, you've got a real chance for conceptual understanding, and you can use it in lots of different scenarios. So that's why I try to avoid using foil. It's limited in its usage. There we go. So we've done a little bit of that. Again, I'm going to give people a chance to try that, because I've done it using drawings, but for time purposes, I think it'd be a nice idea. One thing I would like to show, though, at this stage, I struggle a little bit deciding what's my favorite. Do I want, and this is why these lines are very useful, I can then create the dimensions on the outside. So the first question I think was what? X plus 3, x times 2. Would I want there to be dimensions on the outside like this? So x times x plus 2. Use the copy, make it a little bit quicker. And so it's on the outside of my rectangle. Now it might be you actually make a rectangle and use these vertical lines to do that. So you can see the dimensions on the outside, and this is the area. This is going to be the term x squared plus what? 5x plus 6. So just worth playing with those horizontal and vertical lines. If you like it that way, you might think that adds extra confusion onto the screen, because sadly I don't think I can shorten these lines. I know on Braining Camp, you can go and draw. So you can draw what you want, so you get the size that you want. Very professional drawing there. But that's why I'm introducing you to which ones do you want to use. So let's give you some examples to give you a chance to play with those for a couple of minutes. And then we're on to the final part, which is factorising. I'm imagining a classroom.
Tom, just as we're doing that,
yes.
There's just a little question about how you move away from students basically just grouping things together to then putting them into like a formal array. So like in the video, like they set it out obviously in an array to make it nice and clear. How have you in the past moved students from just kind of randomly putting tiles down to actually putting it into a nice array?
Okay, so let's make that on screen in just a few moments. So I will quickly go onto screen if I may. I've got 1 lot of x plus 2, and now I've got 2 lots of x plus 2. And I'll be honest, this is where actually I think having the physical item on the visualizer in front of pupils will be really important. So we can see 2 lots of x plus 2 there, yeah? I would then actually just do what I've made a rectangle. And I've done it on without a piece of paper, so I can't write on it. So give me just a moment. I've made the mistake of writing on this table before, and it does not rub out well. So I had 2 lots of x plus 2 there, so 2 lots of x plus 2. I would literally be on screen saying I can make a rectangle, because that rectangle is going to have real value to us when we're factorising later on. And you talk about the dimensions there. So I probably, to answer that question, if it does answer the question, I would physically show you doing that. And I think that's where the manipulatives are better than using the screen. You're actually doing it on the visualizer. I hope that answers that question. Let's put some questions back on for multiplying double brackets. I just realized the irony of me only giving using questions that you can answer with one. Oh, I've just seen the spelling mistake on there. Oh, how embarrassing. I hate spelling mistakes. No one's pointed it out though, so I got there first. It sounds Canadian. Any thoughts about the about the links? For time purposes, I think I'm going to move on, if I may, people. So apologies if you haven't had as many opportunities to expand double brackets there, but certainly you've got the idea. Whether you'd use, as I've suggested, maybe if I go across the algebra tiles here, this idea of showing that rectangle, what's going to be on the inside of it. Again, I do think these other lines, I wish I could make those shorter. Maybe that's something you could do on your own screens if you're using certain kind of technology in schools. But you can see the dimensions of the rectangle here. So you could write x plus 3, you could write x plus 2 there. So I'm sure you can come up with your own ways of making that nice and clear. So the most fascinating thing that I found when I started to use these tiles was this idea. Making this idea, and certainly for primary teachers, this is one of the most valid things we're going to do today. Area of a rectangle and factors of number, we can represent them the same way. So here, if I'm making an area of 10, I can make it using a rectangle of 2 by 5. And here we can see, of course, shows us factors of a number 10, but how many other factors can I make with 10? So if I go to screen, if I just go to the camera to do that, I'm just going to do that example, if I may. So I've just mentioned it, and I think this is where counters really come into play. I have made a rectangle of area of 10, and again, the link, being aware we're talking about area a lot in this, but I can make another rectangle as well. I can make that rectangle. I can make 1 by 10. So the factors of 10, I'm just going to use another piece of paper. The factors of 10 come from the fact I can make those rectangles. I'm sorry, I've broken that. So it was 1 times 10. And 2 times 5. There is no other rectangle I can make using these tiles. And you let the children try. Can you make another rectangle? You can't. However, let's go down to 5. Factors of 5. How many rectangles can you make with 5? And the answer is quite simply 1. It's 1 by 5, which means it's a prime number. And it gives us our definition of what a prime number is. 2 distinct factors. That is the definition that we should be using, not can divide by. We've got a really great opportunity when meeting factors in primary school to be pointing out that this here, 5, the only rectangle I can make, making that link to area of a rectangle, but 2 distinct factors. Those factors are 1 and 5, and there is no other way of making the rectangle. And that's certainly one of the biggest links I'm going to make, certainly for Key Stage 2 today. So what should we say factorising means? Put your hand up if you have said factorising means put into brackets. Yeah, I've done it. We've all done it, but is that what it is? That's not what factorising is. In my 90-minute video, which again will be shared on the email after this, about teaching for mastery. I talked about the NCTM glossary, really, really, really worth downloading. Factorize, it's a key stage 2 word, to express a number or polynomial as the product of its factors. So there we can see factorizing 12. If I factorize it, I show it as 1 times 12. If I factorize it, I show it as 2 times 6. If I factorize it, I show it as 3 times 4. If I factorize it, I am showing there are 2 terms. So the one at the bottom, x squared take away 4x take away 21. I am showing 2 terms that multiply to become the product. The 2 factors of x squared minus 4x minus 21 equal, the factors are x plus 3 and x minus 7 because they multiply together. And that's where the area of a rectangle in algebra tiles really has such an important place here. It's not put into brackets. These 2 terms multiply to make that expression. So final video from the NCTM. I think we just about got time for it, so I'm going to go for it. Factorise expressions, and this is, I think, about 2 minutes long as well.
We can factorize numbers, but how do we factorize algebraic expressions? Let's look at some of the ways we can use algebra tiles to support students' understanding of factorization. When the terms in an expression have a common numerical factor, we can group the tiles to show this. We can represent the expression 8x plus 12 using algebra tiles. We can arrange the tiles into 2 equal groups of 4x plus 6. But 4 groups of 2x plus 3 is also possible. We can arrange the tiles into a rectangle to show the expression as a product of 2 factors. The dimensions of the rectangle show how we can write the expression as a single term multiplied by 2 terms. Now let's find the factors for some other expressions. The expression 3x squared plus 5x involves x squared and x terms. It's not possible to arrange these tiles into equal groups as there isn't a common numerical factor. However, we can arrange the tiles into a rectangle with dimensions x and 3x plus 5. For the expression 2x squared plus 16x, there are several ways of factorizing. We can arrange the tiles into 2 equal groups, which shows one possible factorization of 2 multiplied by x squared plus 8x. We can also arrange the tiles into a rectangular shape. The dimensions of the rectangle reveal a different factorization, that is, x multiplied by 2x plus 16. There is another way to arrange the tiles as a rectangle, this time with dimensions 2x and x plus 8. We can see that the full factorization of 2x squared plus 16x is the product 2x multiplied by x plus 8. Here's a recap of the ways we can use algebra tiles to learn about factorizing expressions.
I immediately see an issue, and I'll try and cover it, but I don't think it's something we can do very easily in this kind of format. We've got the same expression there, 2x squared plus 16x, in 2 different ways. How do you choose? How do you get the kids? I mean, I would say you give them 2x squared tiles, you give them 16x tiles, and ask them, can they make a rectangle? If they can make a rectangle, it means it can be factorized. However, how do you encourage them to use the highest common factor? And I actually believe that'd be something that you want to do as a group. This isn't the right scenario for it. If someone types stuff, that's fantastic. Please do put it in the chat during the time. We're not going to get much time to practice, I'm afraid. But how would you encourage them to be the highest common factor? I suppose it's, can you make a longer width? Would be one suggestion, but that's something I really want to explore with people. So I think factorizing the key issue here is, can you make a rectangle? If you can make a rectangle, it can factorize. So if I can make a rectangle using the terms involved, then I can factorize that number. So 2x squared plus 16x, yes, I can make it. Here, 6, I could make the rectangles. 5, I could only make one rectangle. So I've already talked about the link to prime numbers there. My advice when you're doing this, start with the largest tile and then alter the orientation. Now it says, let's try an example, so I will quickly do that. But I think then we're going to be running out of ideas, out of time, sorry. It said x squared plus 4x plus 3. So I'm going to get the... Now, if I just put them all on the same side, I can see that I'm not going to make my rectangle. And here's the fun. Here's the opportunity for the pupils. It's not something I've talked about a lot today. The pupils get a chance to play with this, saying, well, that won't work because the dimensions of the ones, I can't put it alongside there. So I know the orientation is going to have to change. And you suddenly have a little bit of reasoning about it, going, oh, there's 3 there. That means there's 3 opportunities, 3 options there to make the complete rectangle. Some of you may have started realizing completing the square is really quite beautiful on this topic, but that's not for today. As a matter of fact, let's change the expression. X squared plus 4x plus 2. Can you make a rectangle using those tiles? No, you can't, which means cannot be factorized. And that is where some of the conceptual understanding can really come in. X squared plus 4x plus 2, you can't be factorized, I don't believe. Not using the terms that we use at GCSE anyway, or maybe any other term, I don't know. So moving on, those are the kind of things I'd be asking you to do. But I'm going to have to go through these quickly now, I'm afraid. So I'd have asked you to do 3x plus 9, make that a rectangle. But imagine, and this is where I want to end, so it is the final point. Conceptually speaking, we know the area of a rectangle is its length multiplied by its width. So what do we know if we're told that the area is equal to 0? We know the length equals 0, or we know the width equals 0. And this is where it can be really powerful. Because imagine those questions. If I'd have given you time, my apologies, we have run out of time more or less. But if I'd have asked you to factorize those, you'd have said the top one, 3 lots of x plus 3. Well, that means, hold on a second, we can extend these to solving equations that equal 0. So let's just do a couple of them. 3x squared plus 9x, you'd factorize it to be 3x by x plus 3. But if I told you that that area suddenly equals 0, then we know 3x equals 0 or x plus 3 equals 0. The conceptual understanding opportunity here is huge. It's brilliant. I love this part of it. So you can extend the, after factorizing, extending it to equations equals 0 is a really nice opportunity. Here's another one, x squared plus 5x plus 6. If we were to factorize it, you know, therefore, that x plus 2 equals 0 or x plus 3 equals 0. And you've got your 2 solutions. I've chosen this one as well because I think it's a really fascinating one. You can use it for this as well. There's my 2 dimensions, if you like. I've put them on, I should have put that on the width, shouldn't I, not the length. But 3 equals 0, we know that can't be right. So there's only going to be one solution this time, x plus 3 equals 0. So obviously the solution is x equals -3. So to reflect, how would you use these tiles in lessons and learning journeys? The main thing I said earlier on was making sure the pupils are fully able to use these tiles early doors. It is not a rush. Make sure they use them and comfortable at the very, very beginning, and then you've got them for the 5 years of their secondary school. And if, of course, I'm referring to the secondary schools at the moment. Which phases of the lesson? Well, when they come in, make a rectangle with these tiles, for example. They can just sit down and start playing with them straight away. When you're trying to get them to explore, there's opportunities there. If you are lucky enough to be in a school where kids all have their own equipment and they can use laptops and whatnot, they can be going straight onto MathsPop. We talked about that earlier on. Take the time to ensure pupils can show a range of expressions. Really do please take the time over that. Those starters, when I asked you to think about those at the beginning, I just wonder now, would you do anything different, I wonder? We didn't do equations today, but we can certainly see that 2b is a like term to 5b. And 2b plus 6, they are completely separate terms, so that by using tiles, this misconception would not happen. These are the 5 big ideas from the NCTM, and I wanted to remind you all that you should be signing up for the Maths Hubs to see what kind of stuff's going on. It's changed my pedagogy, and I love sharing it with you, and I love having had the time to do that with you today. Those are the websites I mentioned before. And the references, just to remind you, to go to the Improving Mathematics in Key Stage 2 and 3. It's a free document. Just type in that sentence, Improving Mathematics in Key Stage 2 and 3, and you'll download it. But I will end on this screen. Please go and have a look. A reminder myself, my name's Tom. @Mathematics is my Twitter. If you enjoyed it, feel free to share it on Twitter. I hope you found that useful. I'll be on again next Friday at 10 o'clock. We'll do Algebra Tiles again. We'll go a bit further into it, but we will cover more of these Teaching for Mastery ideas. But thank you very much for taking the time. There wasn't much abuse sent, which was appreciated. If you've got any questions, I'll stick around for a short while. But thank you very much for taking part in today's session. We stayed over 100 for the whole thing. That's not bad. That's not bad.